Hi guys, today's lesson is on mixtures and it should be quite a short one, so let's get started. The first question says, what is the name of this compound, NaCl? Well, if you remember, by looking at the periodic table, look for the capital letters and find the name of the element. So the first one is sodium and the second one is chlorine. But when chlorine is bonded in a compound, it changes and it becomes chloride. So sodium chloride. The next question, how many different elements are in NO2? Well, how many different capital letters are there? There's 1, 2, so 2 different elements. The final question, what is the definition of a compound? Well, a compound is 2 or more different elements chemically bonded in fixed proportions. So you'll need to know this for your GCSEs, so it's a good idea to learn the definition. Let's get started with today's lesson. Here are some common mixtures. You've got a mixture of flours, a mixture of sweets, drinks and pegs, just types of different things put together. And you'll notice that none of these are bonded together. If you wanted to separate the yellow sweets or the yellow flours or the yellow drinks, you could do it quite easily. You wouldn't have to do a chemical reaction, you could just pick them out and remove them. And that's an important thing about mixtures. Mixtures are different things put together but not chemically bonded. So here's the definition of a mixture, and you'll need to know this one as well for your GCSEs. I'm going to draw a mixture now to try and simplify what I mean. So you could have a mixture of substances. You could have an atom, so here's our blue atom. You could have an element, so 2 atoms bonded together. Or you could have a compound. So remember, a compound is 2 or more different elements. That's why I'm doing different colours. So this would be a mixture of substances. You'd have your atom here, an element here, and then a compound here. Now notice that the atom, element and compound, they're not all bonded together, they're a mixture. Now let's have a go at this question here to see if we're getting the hang of it. We've got 3 different substances and 5 different descriptions, so we need to link them to the correct one. Let's start off with one of the easier ones. Air's a bit tricky, carbon dioxide is sort of in the middle, but argon is the easiest one. Argon can be found on the periodic table, so we know that that must be an element. Now we're left with air and carbon dioxide. Well, another tip is to get rid of any keyword you've not heard of yet. We've talked about compounds, so we'll leave that one there. We haven't discussed hydrocarbons, so let's get rid of that one. And we haven't discussed metals yet, so let's get rid of that one. Now you've got 2 choices left. So is carbon dioxide a compound, or is it a mixture? Well, carbon dioxide is made of carbon and oxygen bonded together, so that one is a compound. Air is a mixture of different elements. We've got oxygen and nitrogen, and it's also got things in there which are compounds, like carbon dioxide. So air is a mixture. So now we're going to look at comparing a mixture and a compound. How do their properties change? Well, the first one says, are the substances joined together? If we look at a mixture, you'll see that they're not joined together. The blue sweets are separate from the yellow sweets or the orange sweets. They might be touching, but they're not bonded together. In water or H2O here, this compound, you can see these lines, and that line represents a bond. So oxygen is bonded to hydrogen. They're connected. So they are joined together in a compound. Are its properties different to its elements? Well, here the blue sweets will always remain the blue sweets. They're unchanged. Now if we try and think about this in more of a chemical term and look at the elements that make up water here, water is made up of hydrogen and oxygen. Well, on its own, hydrogen and oxygen are a gas. The elements are gases. But when we bond them together, like we have here to make a compound, well, water's a liquid, so its properties have changed. They're not gases anymore. Once they're bonded, their properties change. So in a mixture, they maintain their own properties. Oxygen's a gas, and hydrogen's a gas. But when you bond them together in a compound, their properties change. Let's have a look if it's easy to separate. If I wanted to separate the blue sweets from here, that would be really easy. I could just pick them out. Straightforward. But if I wanted to remove just the hydrogen here from water, that would be really hard because I'd have to break this bond. So we'd have to do a chemical reaction. So mixtures, very easy to separate, but compounds, very difficult. You have to do a chemical reaction. The final question says, can you change the amount of each substance? Well, just like I can take out blue sweets, I can put more in, and it doesn't really affect the mixture. Okay, you add more blue sweets, but all you're doing is just putting more in. If I wanted to add more hydrogen to this, well, I can add as much hydrogen as I like, but it still doesn't look like this. This is now a mixture of hydrogen and water. It's not changing the amount of compounds you have. So you can change the amount of substance in a mixture, but you can't change the relative amounts in a compound. They have to stay the same. H2O, water, is always just 2 hydrogens and an oxygen. And that's it. That's all you need to know for a mixture. So I'm going to leave you with 4 questions to have a go at. Let me know if you need any worked examples in the comments below, and I'll do them for you. Okay, see you next time.